Welcome to our presentation. This is the heads-up display targeting and monitoring team. So the team members in this group is Minh, Z, Matthew, and Faris. So the purpose of this project was to build an app that uses AR to display human physiological data as well as projecting medical images. We started on an iOS app that runs on devices with LiDAR, so we could have curvature on our images. The expectation for this project is to have an external oximeter connected to the app and display heart rate and blood oxygen level. As well, with the information, we would place an AR model of the heart that would beat according to the detected heart rate and change color according to the detected blood oxygen levels. As well, we wanted to place a medical image on the back of a patient's body, for example, an X-ray. We were able to meet the above expectations, but we were not able to get the detailed specifications correctly. For example, we wanted to have models accurate to 1 millimeter for usage in the medical field, but we were not able to meet that.
Welcome to a demo of HUDTarM, an AR medical app. Today, we will showcase the features of this app that can help you visualize a human heart, display real-time heart rate and blood oxygen levels from a pulse oximeter, and display AR medical images over a person's back, such as an X-ray, using Apple's AR Kit and automatic pose detection. To begin, let's connect the pulse oximeter to the app. The oximeter connects instantly as soon as you turn it on. Now, we are just waiting for the oximeter to calibrate. As you can see, the app is now detecting the pulse oximeter and is displaying real-time heart rate and blood oxygen levels. Now, let's visualize the heart in AR. As you can see, the heart is now displayed in 3D. You can move around the body to get a full surrounding view. This feature is particularly helpful for medical professionals who want to explain the anatomy of the heart to their patients. Our app can also display AR medical images over a person's back, such as an X-ray. You can place points manually on a person, which can show an image on a person's back. As you can see, this image is also placed in 3D space. You can get a full surrounding view of how it stays on the person. But who wants to place those dots manually? Using Apple's AR Kit and automatic pose detection, those points can be placed automatically. This means that the app can detect the person's pose and display the AR image accordingly, making the experience much more seamless and user-friendly. The app is displaying an AR X-ray of their spine and back. This feature is particularly useful for medical professionals who want to explain spinal conditions to their patients. As well, our app works with anyone, regardless of body type or any other differences. As we can see, the app is also able to display the heart of this person, as well as the X-ray image. Everything is scaled to the dimension of the user being scanned. Our app also lets you control the opacity of the image placed on the person. If you are looking for a certain amount of transparency for your educational needs, this app does it all. And that's it for our AR medical app demo. We hope this app can be a useful tool for medical professionals and patients alike, allowing for a more interactive and educational experience.
Throughout the project, we were able to finish many goals that we set out for the preliminary design. The most important goal that we set out is to be able to automatically display a generic X-ray image on top of the patient's body. By using the power of Apple's AR Kit body tracking functionality, we were able to detect the patient's body automatically. Furthermore, not only this automatic feature can be done when the body is not moving, we have expanded this feature to be able to work with moving body. We found that by switching back and forth with different configurations, from body tracking to word tracking and vice versa, we were able to achieve the best of both worlds. As LiDAR technology only works with still images and not body tracking, first, we designed it to enable the body tracking functionality to gather the points for anchoring the image. Then we map the image in the word tracking functionality to utilize the LiDAR technology. Secondly, the driver for the pulse oximeter is working properly. The driver is designed so that the app can automatically connect the sensor without any human interaction. By seamless connection towards the sensor, we were able to get the physiological data such as the heart rate and the blood oxygen value for further processing. However, we found that this independence of human interaction can be a limitation. Further work is required as we will explain below. Thirdly, by utilizing the values from the pulse oximeter, additionally with body tracking from ARKit, we were able to process these values to display a 3D heart image on top of the patient's body. As many software projects, the importance of software maintainability is one of our priorities. Therefore, the code has been converted from the legacy storyboard framework to a more modern Swift UI framework, thus allowing the lifespan of the software portion of the project to be more future-proofed.
Some important features that unfortunately did not work are the medical image appearing to be behind any real-life objects placed in front of it, and the placement of the medical image being accurate to 1 millimeters. The first feature is important for working with the placed medical image, as being able to clearly see your hand or a marker or maybe a syringe will be essential in this project's medical applications. This is a rather difficult implementation since objects placed in an AR model is similar to an overlay on the device's camera, which means by default, AR objects will appear in front of everything in the real world. One possible way to make the AR image appear behind any real objects is for the app to first recognize and track the depth and the shape of the real objects. Then, the AR image would need to be cropped around the real objects. This needs to be accomplished real time as well. However, as a workaround, there's an option to make the AR image more transparent, which would help the users see their hands or any other real objects. So, this must be used as of now. The second feature is important because for the use of the app in critical medical situations, accuracy is essential. However, and especially for the automatic placement of the medical image, the AR image is placed in a way that is only accurate to few centimeters. To improve this requires a more accurate automatic body joints detection. This could mean a manual development of body tracking that combines the use of machine learning and LiDAR, which is what makes higher accuracy a difficult task.
This app can be extended for many other use cases. I'll firstly go over the future work that can be done for the current use case before branching out to different use cases of the app that our client suggested. Currently, the 3D heart and the medical image will be attached to the user's body even if the user moves or the camera moves, but there's a slight delay on the updating of the medical image. This error is more prevalent when the patient or the camera moves faster and the tracking will not be as efficient. Hence, this can be further developed to be able to track bodies more efficiently when there's greater movement. In the current iteration of the prototype, the app will automatically connect to only one pulse oximeter within the range. This can be a problem if there are multiple pulse oximeters present, as there's no current option to select which oximeter to connect to. Ideally, there should be a list of pulse oximeters to connect to and choose from, and should be implemented in the future. To further improve the functionality of the app, more sensors can be added or the capability of it. Currently, it only works with the pulse oximeter. A sensor our client wanted to work with was the Apple Watch. However, through some research, we found that the Apple Watches were not compatible with the iPad device. Therefore, if the technology improves for the iPad, this could be a viable option to include in the future. Another improvement to the app will be to allow for different medical images of different body parts. Currently, it only works with images on the back, which is limiting to just back surgical procedures. Therefore, by implementing this feature, this will allow for the app to help out with wider range of procedures. This should not be too hard to implement, as it's still using ARKit's body detection features, and in picking out the right points to extrapolate from will be the difficulty. Along with this point, adding different organs can help as well. Our client mentioned that this app can be used for educational purposes, and by adding more organs, such as the liver, will allow for students to have a better understanding of the human anatomy. This feature can also be implemented using AR's body detection software. Multi-body detection could also be a feature worth implementing. Currently, our app only targets one body, and this can be a hassle if there are multiple humans in frame of the camera, as the body detection system may not be able to pick the right body. Hence, with this feature, we were able to detect multiple bodies. We can further extend this feature. For example, if multiple sensors can be implemented, we can then extend the app to work with multiple people. Our client also mentioned that the app could be used for gym instructors, as they could monitor the client's physiological data with the app, and hence this feature would also help out with that.
In conclusion, we were able to meet most of the functional and performance requirements set out by our client. We were able to design an application that was successfully able to connect to an external sensor that fetched heart rate and blood oxygen level data, a pulse oximeter. We were able to use LiDAR sensors to accurately map out the curvature of objects so that we could place images on top of them, thanks to the iPad and iPhone's LiDAR sensor. This, in turn, also limited us to the latest iOS for development and prototyping, because iPhones and iPads are the only commercially available mobile devices with LiDAR sensors integrated into them. Apart from the initial requirements, we were also able to meet some of our stretch goals, such as adding a 3D heart that reflected the data from the oximeter, beating with the given heart rate, and color changing with the given blood oxygen level. Overall, the project was a success, though we did encounter some difficulty in accurately placing medical images and determining body joints, which we overcame using Apple's ARKit's body detection capabilities. There is definitely some room for future work to be done to further improve the product, but we as a team have met most of our goals.